Have you ever stopped to think about what happens when you flip a light switch? The room floods with light instantly. We take this invisible magic for granted, but in the fraction of a second between your finger hitting that switch and the bulb lighting up, an epic journey takes place. Today, we are tracing the exact path of electricity, from the moment it is born to the second it powers your life. To understand electricity, we have to start by zooming all the way into the microscopic world of atoms. Inside, every atom is a center called a nucleus, surrounded by tiny buzzing particles called electrons. In most materials, like wood or rubber, these electrons are held tightly in place. But in certain metals, like copper or aluminum, the electrons on the outside are loose. If you give them a little push, they bump into the next atom, knocking its electron to the next, and so on. This continuous flowing river of jumping electrons is what we call an electrical current. But how do we get those tiny electrons to start jumping? They need a massive push, and that is where power plants come into the story. Whether it is a coal-fired plant, a hydro dam, or a wind turbine, they all do one simple thing: spin a massive magnet. Inside, every power plant is a generator where huge magnets spin around giant coils of copper wire. As the magnets spin, they violently push and pull the loose electrons in the copper. We have just generated a massive flow of electricity. Now we have to move that power, and we need to move it fast. As electricity travels through wires, it loses energy as heat. To solve this, the electricity is sent through a step-up transformer right outside the power plant. This machine cranks the electrical pressure, called voltage, up to hundreds of thousands of volts. This extreme high-voltage electricity is then pushed onto the transmission grid, traveling across the country on giant steel towers. Eventually, this superhighway reaches your city. But bringing hundreds of thousands of volts into a neighborhood would destroy your appliances. So, the power flows into a local substation. Here, a step-down transformer acts like a pressure valve, reducing the extreme voltage to a safer level. It travels down the distribution lines on your street until it hits one final transformer, usually a gray cylinder on a pole. This drops the pressure to the standard voltage used in your home. The electricity passes through your meter, enters your switchboard, and waits behind your electrical outlets. The second you plug in your phone or turn on your TV, you complete the circuit. The electrons rush out, power the screen, and return to the grid. It is a continuous, unbroken chain of moving energy, connecting your device all the way back to a spinning generator. If you found this journey fascinating and want to understand the hidden world of electricity around you, hit that subscribe button. Thanks for watching, and stay curious.